things in one glass envelope that came out the twin triode. It's just two almost completely separate triodes in the same glass envelope. So typically, like the heaters will have a common center point, so you have 3 wires for the heaters. And that allows you to run the heaters in series or parallel, right? So that's what we're talking about here. They can run series or parallel. And that's when you talk about like a tube with a 6 in front, means a 6-volt heater. All right, the numbers in front in the American system indicate the heater voltage. So a 6 SN7 GT has a 6-volt heater. A 12 AU7 or 12 AX7 not only has a 12-volt heater, but that's considering running it in series. You can also run a 12 AX7 with the heaters in parallel and run them at 6 volts. Now, this series of tubes, 12 AU7, 12 AX7, 12 AT7, 12 AY7, are all pin compatible. So a common, cheap, simple modification you can do to tube amp is if you think it has too much gain, you can swap out the 12 AX7, which is a high mu, high gain tube, with the 12 AU7, which is a medium mu tube, and you reduce the gain of the circuit. And if you need to go further, you can go to an AT or an AY. 6 SN7s are older tubes. You'll find them in older amps. I have the head I have, there's actually a converted PA head that uses 6 SN7s. It was converted from being a power, just a public address amplifier to being a guitar. And they have a different characteristic. They're not as common nowadays. The 12A blank lines have pretty much replaced them. But you do find it in older amps. All right, so after the triode, we get to the tetrode. Now, as you know, it follows the pattern so far. Diode had 2 elements, triode had 3 elements, tetrode has 4 elements. So what it has is an extra grid. And okay, well, we've got the control grid with the input signal. Well, what's this extra grid for? It's strictly there to reduce capacitance. Right? So you play more gains, it acts as an electrostatic shield, and it has spaces, the control grid, like I said, is not super tightly packed. It's not really loose. Well, this one is really loosely packed. It's a very wide open spiral, and you can kind of see that in this diagram. And what they do is they put a high voltage on the screen grid. So, well, okay, say that's bad, it attracts some electrons. And yeah, it does. That's a problem. But the plate voltage itself becomes less important. So you keep the plate voltage higher in the screen grid, but the current depends more on the screen grid. So since the current is independent of VP, you can get more amplification and less grid to plate feedback. Okay, by adding this extra grid in there. And according to the manual, it says this is similar to using transistors in a cascode configuration. The games we play to increase our amplification. After the tetrode, we get to the pentode. And basically the issue here is, well, okay, we've created this 4th grid, and we put it at a high voltage, right, but less than the plate. Well, some electrons hit the plate and bounce off, because they've got a lot of energy. And since the screen grid is at a high voltage, some get attracted to the screen grid, so we have this extra current flowing in the screen grid. That's wasted. So what we do is we throw a 5th grid in there, and this grid we put a ground potential, so that if anything goes through here, past the screen grid, bounces off the plate, the next thing next to it sees is the ground potential. It's not attracted to that. It gets sucked back to the plate. Okay, so it's kind of adding these extra things to guarantee we get the most amount of current to the plate that we can. That's the idea of adding the elements. And it allows us to operate at higher amplifications. It allows things to operate more efficiently. So one of the higher output with lower grid driving voltages, better voltage amplification with moderate plate voltage. So a common tube that we see is the 6BQ5. That's also an EL84. Now that's not a really big power tube. The actual, like the bigger ones that you may be more familiar with are beam power tubes. And what they do is they have another way of amplify anything. Instead of adding grids to affect things, they add masks. So instead of the electrons flowing at 360 degrees, they limit it to a beam of maybe 40 or 50 degrees, or a couple of beams. And that gives you, it's another way of producing these secondary emissions that the pentode was originally introduced to do. So you see things that are beam pentodes, or you see beam tetras, and again, so these are more common tubes that you probably have seen. The 6L6 GT, that's a very common like Fender tube. 50L6, very common in Widowmaker amps. Again, 50 is the heater voltage. Notice that. 6AQ5 is a common power amp tube for little amps, for something akin to that 5 watt, 7 watt class. Sometimes you even see two of them put together in a push-pull configuration. Okay, to talk about bases, I hinted at this a little bit. Originally, you had things that were like these 4-pin thick bases, so it would look like this, but it just got 4 pins on it. These are kind of the standards right now. Most tubes use these. The Vibro champ I brought in uses 2 octal tubes and 2 9-pin miniature tubes. And the way you look at them is, octal has 8 positions. So there are 6 pins here. There's another position here and another position here. It's got a Bakelite phenolic base, and it's got a center tab that's made out of that base that has a locator tab. So the 8 positions are equally located, but that locator tab guarantees you only put it in one way. The 9-pin mini, actually what it has is it has 10 positions, and the 10th one is left blank. And the socket doesn't have a hole in that position. So you locate it by lining up this gap on the tube with the gap in the socket. And those are the common ones. Like I said, previously you had 4-pin ones, and some tubes actually had a little clip on top. So they may have 4 pins on the base, but they actually have a 5th connector on top. Then they came to kind of like the heyday. You had 9 pins. You also have some 7-pin minis, but the 9-pin and the octal are the big ones. And then in the later years, like I said, you get to the weird things, the compactrons, as they were called. And this is where you get to triple triode. 6U10, which is a tube used in, Ampeg used in a reverberocket amp, is actually 3 triodes. And it's this 11-pin thing. It looks kind of like a squat water tower. It's big and round and kind of not as tall. And then you get into new visors, which are kind of amazing. And I think ZVAX access and products use them. They're actually leaded tubes. They're not socketed. You just solder them into the circuit. They have that kind of longevity, but they're small. They're like a 5th of the size of a 12A set. They're pretty amazing. And that was kind of the high technology tube before solid state took over. All right. So let's talk briefly about tube characteristics. You've got static and you've got dynamic. All right. So static characteristics are what's shown on the plate characteristics, right? Just like you look at a curve tracer with a transistor, where you get you get curves with a tube. So if we look through the RCA tube manual, you'll see they have characteristic figures. Let's see which figure 41 shows a curve of plate voltage versus plate amp, and you have different curves for different grids. So you actually go through and you bias the tube with the right plate voltage and plate current based on the grid voltage. And so these things are determined statically, but then you also have dynamic characteristics, which are more how they affect the AC signal. You've got the amplification factor, which is the mu, the plate resistance, and the plate transconductance. Okay? So dynamic factor. The big one is mu, right? And that's kind of simply defined as the ratio in a change of plate voltage to a change in control voltage. But of course, it's in the opposite direction, right? Because any single device amplifier